Hi, grade 10s. Welcome back. This lesson is a continuation of the trigonometry that we have already covered. So this will be a shorter lesson compared to the first one. Okay, hence I wrote part 2. So this is the part 2 of the trigonometry. Please make sure you watch the first part or part number 1. So this lesson is dated 7 April 2020, which is a Monday, and it's mainly for grade 10 learners. Okay. However, grade 11 and 12 may also use this as a starting point for basics. Okay, very good. Now, lesson objectives for part 2 of trigonometry, we'll be looking at angle of elevation as well as angle of depression. Okay, and we'll also look into application. How do you apply these into questions? And we'll look at the summary of the lesson. Right. So, what is the angle of elevation? Okay, and what is the angle of depression? So, first of all, angle of elevation is sometimes called the angle of inclination. Okay, so in your test or your exams, if we do not use angle of elevation, we may use angle of inclination. Okay, so what are these angles of elevation and depression? Right, so I have a few notes for you here. Say for an example, you are standing, not looking at anything, so it means your eyes will be facing a horizontal level direction, and then say there is an airplane which is above the ground and above you, which is passing by your area or something like that. What is going to happen? Obviously, you're gonna move your eyes from a horizontal level, and you will want to look at the airplane which is passing by. Okay, so what is going to happen? Obviously, from the initial level of sight, you're going to move your eyes up to the object. Right. So, in that way, you have actually created an angle between your original line of sight, which was the horizontal, and the new line of sight, which is now diagonal to the object. Okay, so the angle between the line of sight, the initial one, which is the horizontal, and the new line of sight up to the object, we call that angle the angle of inclination or the angle of elevation. Okay, similarly, if initially your eyes you're not looking at anything, and then maybe there is a rat or a mouse which is moving past you on the ground, so you're going to move your eyes from a level of from the horizontal level, and you're going to look down to the object. Right. So immediately you do that, you have created an angle from your horizontal line of sight as well as the new line of sight, which is to the object. Okay, the object being the mouse. So in a way, what have you done? You have created an angle, and this angle is called the angle of depression. Okay, quickly, what's an angle of elevation? Angle of elevation is the angle between your horizontal and the line of sight up to the object. Then what is the angle of depression? It is the angle between the horizontal and the line of sight down to the object. Okay, so when we talk about elevation, we look up. When we talk about depression, we look down. Okay, now, having said that, you need to note that since these two angles, they form what we call a Z shape. Okay, and we have a horizontal in the case of elevation, we have a horizontal in the case of depression. But what we know about the two horizontals, they are going to be parallel to each other. Alright, hence making the angle of elevation to always equal to the angle of depression due to alternate angles between parallel lines. I hope that is very, very clear. So if you are given an angle of depression, just know that you already have the angle of elevation because they will be equal. Or if you have an angle of elevation and you are asked to find the angle of depression, just know that you have it because they will be equal due to alternate angles. Okay, so grade 10, there is what we call bearing, which is what we use for direction of objects. In grade 10, it's not necessarily important. However, you do a bearing in your social sciences, etc. But in math, we are mostly focused on angles of elevation and depression in grade 10. So bearing is mostly done in grade 11. Hence, you don't really need much of bearing information. Okay. However, you need to know the angles of elevation and angle of depression. All right. Now, having said that, let's go straight to the examples. Okay. Take your time, pause the video, do the example, then compare your solution with the solution that will be provided here in the video. Okay. Now, example 1. A man is watching a boat on the ocean from the edge of a 300-meter high cliff. Okay. So immediately they tell me that I drew a small picture of the man so that I can show you where the man is. Okay. Now, he calculates that the angle of depression, what is the angle of depression? From the horizontal with the cliff or with his eyesight, right, down to the boat. That is 15 degrees. Okay. His angle of depression from the cliff to the boat is 15 degrees. And I hope you see it on the sketch. Now, what do we know? Since we are given that 15 degrees to be the angle of depression, then we know that the angle between his line of sight to the boat as well as the distance between the cliff and the boat, that angle between those two will be also 15 degrees because these are alternating angles. Look at the sketch. I have written down 15 degrees because I'm using the fact that angle of depression will always be equal to the angle of elevation or inclination. Right? You need to do some working on your sketch so that you do not forget. Now they are saying, determine how far the boat is from the base of the cliff to the nearest meter. Underline nearest meter, meaning you must round off to the nearest meters. Okay. Now, how far is the boat from the base of the cliff? Meaning, what is the distance between the base of the cliff as well as the boat? Okay. I've let that be equals to x. So since we mathematicians are lazy, so please do not write words to say the distance between this and this is that. No. Just let the marker know that x represents the distance between the base of a cliff and the boat. Okay. Let y be whatever. Just use variables to represent statements. Okay. So how do we find that? First of all, we needed to show the marker that we have 15 degrees inside that right angle triangle, and we have x, which is the variable that I've introduced, and we have 300 meters, which is the height of the cliff. Okay, so now you must relate your angle with the size of the right angle triangle. Remember, in the previous video, part 1, we have spoken about what we call trig ratios, and we said these are relationships between the sides and angles of a right angle triangle. So 15 degrees in this case is opposite the 300 meters and is adjacent the unknown variable x, which is what we are looking for, the distance between the base of the cliff and the boat. Okay, so what trig ratio is that? That is your tan trig ratio. So we are solving for x. Then I said tan 15 degrees equals to opposite 300 over adjacent x. Making x the subject of the formula, it will be 300 over tan 15 degrees. Then when you punch that into the calculator, it gave me 1119.62. Okay, but remember, this is to 2 decimal places, and the question said we must round off to the nearest meters. Okay, therefore, this will be 1,120 meters. So the boat is 1,120 meters from the base of the cliff. This is what the distance between the base of the cliff and the boat. Well done. Now, second example. Pause the video, do it on your own, then come back and check whether you have done it correctly. In a rugby game, Joe has been awarded a penalty kick. Okay, so the fact that people are playing, then all of a sudden they have to go for penalties and all that. So Joe is awarded a penalty kick. Okay, the cross beam of the rugby post is 6 meters high, shown on the diagram. Okay, and Joe is standing 20 meters from center of the posts. Okay, now we have two sides given. We have an unknown angle theta, very, very important. So if Joe is to go for the penalty kick, the only time the ball will be able to go into the post, or Joe will score a point in there, that is when the angle at which Joe will kick the ball is actually within the parameters. Okay, now will Joe score if he kicks the ball at an angle of 15 degrees? So this is more like find the vertical height at which Joe would have kicked that ball, and then compare it to the 6 meters. If the height which Joe is kicking that ball at, given the 15 degrees angle, is smaller than 6 meters, then there is no way Joe will score. Okay, but if the height at which Joe kicked the ball is bigger than 6 meters, then surely he will score. Remember, I want to show you something. Remember, this is where the ball needs to go in. Okay, this is where the ball needs to go in. Okay, very, very, very important. So the only time he can score, that's if he's getting a height bigger than 6 meters. Therefore, the ball will go in. All right. Now, having said that, will Joe score? Let's check. We are going to use the 15 degrees, and we are going to let the height that we are looking for to be equal to y, and then we'll use the 20 meters as well. Now, this is what I have done. I said let theta be equal to 15 degrees, which is the angle that we were given, and we are going to use, and then let the rugby post be equal to y. Okay, so we want to find y. Immediately y is bigger than 6 meters, then he will score. If y is less than 6 meters, then he cannot. He won't score a goal. Okay. Now, 15 degrees is equal to what? The y all over 20. Okay. So when I made y subject, I found that y was equal to 5,36 meters, meaning, okay, meaning when we look at the diagram, this is what we have. Meaning, the height at which the maximum height at which the ball will be kicked at will be from somewhere here and will end around here. Okay, which is really not going to make it because of it's less than 6 meters. For him to score, we must get a height bigger than 6 meters. Okay, so we've seen that the person cannot score because of the height at which the ball was kicked at. Okay. Now, how do you write it down? Since we got y equals to 5,36 meters, you tell us. Therefore, that 5,36 meters is less than 6 meters. Therefore, Joe won't score. Okay, very, very important. Now, having said that, let us move on to question B. Now they are saying, what is the minimum angle at which Joe must kick the ball in order to score? So we are going to use the 6 meters which was given to us, okay, and also the 20 meters in order to see what is the minimum angle that Joe needs to kick the ball at so that he can score into those posts, okay. So theta is opposite 6 meters and adjacent 20 meters. So we are going to use tan again, and then we check what is it that we get. So tan theta equals to 6 over 20, and when we shift tan, I've shown you in the previous video as to how we do that. We got theta equals to 16,7 degrees. Okay. Now remember, 16,7 degrees. Let us go back to our sketch. 16,7 degrees will be what? The angle between the horizontal length, which is 20 meters, as well as the hypotenuse there. Meaning this angle will be the angle that gives us the vertical height up to the point there. Okay. Meaning for him to score, the angle at which he must kick the ball, it must be bigger than 16,7 degrees. You agree with me? Because if the angle is bigger than, then it means we'll be getting something like this. Okay, which will be, this will be that. Okay, so if you are getting an angle bigger than that, then he will be able to score. So as a result, it means, what is it that he needs? He needs to kick the ball at an angle which is greater than 16,7 degrees. Remember, if his angle is exactly 16,7 degrees, he will not score. Okay, so meaning theta must be greater than 16,7 degrees. Not including 16,7 degrees, but must be what? Greater than 16,7 degrees. Okay, so that he will score the goal. Okay, now let us check. I've done that. I've said theta should be greater than. Okay, I think you'll see how I've done that. I said theta should be greater than 16,7 degrees. This is a real life problem. You need to think. Okay, theta must be greater than 16,7 degrees in order for Joe to score. Okay, well done. Now, next problem. Nicole and Jeffrey, I think you see on the sketch, their names are written there, are standing behind each other in a straight line, are watching a flag blowing in the wind. The angle of elevation, okay, of the flag from Jeffrey, you see it there, is 45 degrees, and Nicole's angle of elevation to the flag is 30 degrees. Remember, from horizontal to the object, up to the object, that is elevation, right? So it means Nicole and Jeffrey will be looking up to the pole. That's why we call those angles of elevations. Okay, and then when you look at the diagram again, I've left the distance between Nicole and the flagpole to be equals to x, and I've left the height of the flagpole to be y. I hope you can see that. I've let it to be equals to y, and there we go. Okay, very, very important. And then also we are told that the distance between the flagpole and Jeffrey is 10 meters. That is very important, and I hope you will take note of that. Now, if Jeffrey is standing 10 meters from the base of the flagpole, remember, now the flagpole and the ground will create a 90 degrees at the point of contact, meaning we have two right angle triangles in this diagram. Okay, it's the right angle triangle formed by Nicole, the flagpole, and then we have a right angle triangle formed by Jeffrey and the flagpole. Okay, two right angle triangles. Now, the first case is about Jeffrey standing 10 meters from the base of the flagpole. Calculate the height of the flagpole, meaning we are looking for Y. Looking at Jeffrey. Jeffrey, the distance between Jeffrey and the flagpole is 10 meters. So, how does the angle of elevation of Jeffrey, which is 45 degrees, relate to the sides of the right angle triangle, the small right angle triangle? 45 degrees is opposite the flagpole, which is Y, and is adjacent the distance between them, which is 10 meters. What is that? That is tan 45 degrees. Let's see. So tan 45 degrees equals to Y all over 10, and then we cross multiply. Therefore, Y equals to 10. And this makes sense because of when you look at the small triangle for Jeffrey, sum of angles of a triangle must add up to 180. So if that is 45 degrees, the other angle here should also, the angle there, okay, I hope you see it, should also be 45 degrees, which means this is an isosceles triangle, and if the distance between Jeffrey and the flagpole is 10 meters, then the height of the flagpole must also be 10 meters. Okay, well done. Now, we found that the distance or the length of the flagpole here is 10 meters. Okay. Now, having said that, let us move on to B. How far are Jeffrey and Nicole standing from each other? So the question is asking us to find this. Okay. How far are they from each other? So the first thing that we need to do, we notice that we have to find the whole distance from Nicole to the flagpole. So I'm going to use the big right angle triangle for Nicole, and I'm going to say the angle of elevation 30 degrees is opposite the height of the flagpole, which is 10, and is adjacent X. I'm talking about the big right angle triangle. Okay, and then let's see how I've done that. So using Nicole's angle of elevation, you see I've told the marker. Tan 30 degrees equals to 10, which is the opposite side, all over X, which is the adjacent side. Then making X the subject, I found that my X is equals to 17,32 meters. But remember, I'm not asked to find X. That's not the question. The question is, how far is Jeffrey and Nicole standing from each other? Okay. Therefore, since the distance from Nicole to the flagpole is 17,32, and the distance between Jeffrey and the flagpole is 10, then we can say the longer length minus the shorter length, and that will give us the distance between the two. Okay. So I said let P be the distance between Nicole and Jeffrey. Therefore, P, which is what we are asked to find, is equal to X minus 10. Okay, longer length minus shorter length. That is 17,32 minus 10. And therefore, P is equal to 7,32 meters. Nicole is standing 7,32 meters from Jeffrey. So apparently they are about 7.5 meters away from each other, okay, or 7.3, something like that. Okay, good. Now let us go to example number 4. All right, some of the things on this diagram I've already inserted them, so please make sure you understand that. Now a 4-piece slide is set up between two buildings, and the ground as an emergency escape road. Okay, so what they're talking about is this part here. Okay, this is the part which they are referring to as the 4-piece slide. Now, having said that, the angle of elevation from the top of the shorter building, okay, shorter building being this one, this is the shorter building, is 53,13 degrees. I see it on the diagram. And the angle of depression to the ground, okay, from the shorter building is 60 degrees. So angle of depression is the one that is there on the diagram given, but I know that the 60 degrees alternating angles will give us angle of elevation to also be 60 degrees. That is what I've written here at the bottom. Okay, angle of elevation always equals to the angle of depression. Now, determine the distance between the buildings. The distance between the buildings. So, that is x. We are finding x. I hope you are seeing it there from the sketch. We are finding x. Okay. Not only x, but they also said, and hence the length of the second slide, which is d. Okay. We are also finding d if the length of the first slide is 50 meters. Okay. So what I want you to notice is we have two right angle triangles there, and we need to work with them separately. So the first one that I'm going to use is the top one with the information 50 meters, 53,13 degrees, and x, in order for me to find x. Okay, now let's check how we do that. I've said, okay, before we come here, let's check. How does 53,13 degrees relate to x and 50 meters? 53,13 degrees is adjacent to x and hypotenuse to 50. And that means the trig ratio that you must use is cos. So cos 53,13 degrees equals to adjacent to x all over hypotenuse to 50. Then I found that my x is 30 meters. So this is what? The distance between the buildings. Okay, but we're not done. We also told that hence the length of the second slide. So when you look at the second slide, it's on the second triangle with the information d, 60 degrees, and x. So I'm going to check how does the 60 degrees relate to the sides that are given and the one that I'm looking for. So 60 degrees is adjacent to x and hypotenuse to d. What is that? That is also cos trig ratio. Okay, so this is what I've done. I said cos 60 degrees equals to 30 all over d, making d the subject of the formula. I found that d was 60 meters, which is what? This is the second slide length, the length of the second slide. Okay, well done. Now let's go to B. Determine the height of each building. So we know that from the sketch, y1 represents the height of the shorter building. You agree with me? Okay. And then y1 plus y2 represents the height of the taller building. So let's start by finding y1. What do we have? Okay. So what we have here is angle 60 degrees. I'm starting with the height of the shorter building. So what I'm going to use what I already have. I have x, I have d, and I'm looking for y1. So, and 60 degrees is also there. So 60 degrees is opposite y1 and is hypotenuse to d. Okay. You can also use tan. Opposite over adjacent, it will be y1 over x. So it's up to you. Okay. So let's see how I've done it. So I said let y1 be the height of small building, and then let p be the height of big building. Okay. So sine 60 degrees is equal to y over 60. Here it's supposed to be y1 because I'm finding the height of the smaller building. So therefore y1, when I substituted, it gave me 51,96. I rounded off to 2 decimal places now. Okay, but we're not done. Remember now, we need to find y2, then add it with y1 to give us the height of the taller building. Okay, so how did I do that? Let's check. I said in that smaller triangle up there, 53,13 degrees is opposite y2, hypotenuse to 50 degrees. I'm talking about this triangle here. Okay. Now, if I'm going to relate those ones like that, meaning I'm dealing with sine. Okay, then I said sine 53,13 degrees equals to opposite y2, hypotenuse to 50. Then I found that my y2 was 40 meters. Okay, but remember, the height of the taller building is y1 plus y2. Therefore, adding those, I then said y1 p is equal. Remember, p was my height of the taller building. So p is equal to y1 plus y2, which is 51,96 plus 40, and I got the height of the taller building to be 91,96 meters. Okay, which is the height of the taller building. Good. I hope we are moving together. Now, this is adapted from a past exam paper, and we want to go through it. Okay, so I hope you're going to also practice more of these questions after watching the 2 videos on trigonometry. Now, RQ is a vertical pole, as shown on the diagram. The foot of the pole Q is on the same horizontal plane as P and S. The pole is anchored, underline, the pole is anchored with wire cables RF and RP. Okay, meaning they give us the distance between PQ, QS, and PS. Now, the angle of depression, very important. You see, the angle of depression from the top of the pole to point P, meaning from horizontal to between horizontal and line of sight down to P. That is angle of depression. Okay, it's 47 degrees. PR is 21 meters and QS 17 meters. I think they are shown on the diagram. RPQ, angle RPQ, the angle between line RP and PQ is theta degrees. Okay, now let's see. What do we know about this? I think I'll be just giving a hint. This. What do we know about this? We said this angle and this angle will always be equal because of alternate angles. So this is the angle of depression, and this is the angle of elevation. You see that? Okay, so what do we know about those 2 angles? They will always be equal. Now, write down the size of theta. Theta is equal to 47 degrees, and I think I wrote it for you. Angle of elevation always equal to angle of depression because of alternating angles. Okay, now let's go to 6.2. Calculate the length of RQ. Where is RQ? There is RQ. Okay, they are looking for RQ. Now, since we know that here we have 47 degrees, okay, degrees. How does 47 degrees relate to RQ and the given length, 21 meters? It is opposite of a hypotenuse, which is sine trig ratio. Now, that is on the next slide. First, tell the marker which triangle are you working with. So I said in triangle PRQ. Let's see. This is triangle PRQ here. Okay. So in triangle PRQ, what is happening? Sine 47 degrees equals to RQ over 21. Then RQ happened to be 15,36 meters. Well done. And then the next question is, hence, calculate the size of angle S. Remember now, we know what this is, right? And then we know what this is. So I've got 2 lengths. Okay, I've got RQ, I've got QS, and I'm looking for this angle here. How does this angle relate to these things? It's opposite over adjacent. And what is that? Tan trig ratio. Okay, so let us find angle S. Remember, trig ratios, we use them to find the size of a triangle and the angles. So tan angle F equals to 15,36 over 17, and angle S is 42,10. What? Degrees. Don't forget. If I don't see these, let me show you. If I don't see this and I don't see this, I do not give you a mark. I won't give you a mark because These are not angles. You are not dealing with angles. But if you show me those two things, then it means you are talking about angles. Now, well done. Now, 6.4. If PQS, if all of this here, okay, lie in a straight line, how far apart are the anchors of the wire cables? So it's like they're asking you how far is P and S. So this question is asking you to find the length of PS. Okay, and it's very simple. We will find those, very simple. Okay, so the first thing that you need to find is you need to find PQ. Once you have PQ, you add it to QS there, and then you have the length of PS. You get what I'm saying? Okay, don't forget also you've got angle theta, and then angle theta relates how to PQ and the given length 21 meters. This will be adjacent over hypotenuse, which is what? Cos. Okay. The other thing that you can use to find PQ is your theorem of Pythagoras, because you know this, you know that, and you want this. So you can say PR squared equals to RQ squared plus PQ squared, then find PQ. Okay. And then, now, let us answer the question. We said theta is adjacent to PQ, hypotenuse to 21. That is cos. So let's go to that and show how we have done it. Okay. So cos 47 degrees equals to PQ over 21. Okay. And then PQ became 14,32 meters, of which we said, then if PQ is 14,32 meters, then what do we know? PS will be the addition of the 14,32 plus the 17 meters. Okay, that's what I've done. I then said PS equals to 14,32 plus 17 equals to 31,32 meters. And this is how far they are apart from each other. Okay, very, very simple. Now, let us go to the last question, which is from another exam, past exam question paper, and you need to do it. Okay, a right-angled triangle has sides little a, little b, little c. I think you remember this is how we label the sides of triangles in trigonometry. And the angle theta, okay, as shown below. Now, write the following in terms of ABC. In terms of ABC. What will be cos theta in this case? So we see that theta, there is theta, it will be adjacent to B and hypotenuse to C. So meaning our answer will be B over C. Okay, well done. Now, the next thing is tan theta. What will be tan theta in terms of A, B, and C? Tan theta will be, remember theta is this one, it's opposite A, adjacent B. Therefore, our answer will be A over B. Well done. Okay. Then, sine 90 degrees minus theta. Okay. Don't forget, I said to you, if you have such a question, you start by showing with what? A diagram. So, look at your diagram. Where is 90 degrees? 90 degrees, remember it's from 0 here, all the way up to 90. And this is anti-clockwise. But when I'm there, there is negative theta, meaning I must move clockwise theta degrees. Therefore, where will I be? I'll be in the first quadrant. You agree with me? So since I'm in the first quadrant, what do I know? In the first quadrant, all trig ratios are positive. Okay, meaning my answer, I know it should be a positive. Okay, and then the other thing is, let us look at 90 minus. Okay, this is for particularly grade 11, where you'll be dealing with what we call cofunctions. Okay, where a 90 minus theta will be changing sine to be cos, and the final thing that you'll be having there will be a cos theta. Okay, for now it's not important, but you need to know that when we have cofunctions, let me write them down for you. Cofunctions Ne? It will be 90 degrees plus or minus theta. It will be 270 degrees plus or minus theta. Very important. So whenever you deal with these, okay, you still treat them like your reduction formula to check where they are and how they affect the trig ratio. But remember, 90 plus or minus, 270 plus or minus will change sine to be cos and cos to be sine. Okay, so sine will become cos and cos will become sine whenever you are dealing with what? These. Okay, and another thing, here's a nice way of remembering whether 90 plus, 90 minus, 270 plus, 270 minus will change sine to cos and cos to sine. Remember, on a Cartesian plane, we have this, okay, of which here I have 0 degrees, I've got 360, and I've got 90 degrees, I've got 180 degrees, I've got 270 degrees, right? So, if you are in an agreement with a person, what do? Your head will move like this. Yes, I agree. Okay. And then if you are in disagreement with somebody, your head will move like this. I don't agree. Okay. So, if you're agreeing, what does it mean? Does 90 degrees and 270 degrees change sine to be cos and cos to be sine? Yes, we are in agreement. Does 180 degrees and 360 degrees change sine to be cos and cos to be sine? No, I don't agree. Okay, so that is how you should memorize those ones. Okay, so sine 90 degrees minus theta is equals to cos theta. Okay, 90 minus first quadrant, all positive. But because it's 90 minus, then sine becomes cos. Cos what? Theta. Okay, now let's see how we've written that down. Okay, this is the answer. So if it is cos theta, then let's continue. What will be cos theta in terms of A, B, and C? Cos theta will be adjacent over hypotenuse, which is B over C. Okay, we have exactly that. Now the next thing is 412. They are asking us to find the value of B if A is 5 and theta is 50 degrees. Okay, so I've used B to find the value of B. Okay, I've used B to find the value of B. Just a coincidence, but that's it. So what is tan theta? Remember, my tan theta was equals to A over B. Okay, now I'm given theta, which is 50 degrees. I'm given A, which is 5. Then I found that my B was 4,20. Okay, now going to 4.2, if we are given that A is 38,2 degrees and B is 146,4 degrees, calculate the value of 2 cosec A plus cos 3B. Remember, when we are dealing with your cosec, you need to think of their reciprocals because that's what you can find in the calculator, right? Now let's check. This is how I've done it. This is what was given to us. Okay, this is what was given to us, and then I substituted for A and for B, angle A and B, and then here, remember we have a problem now because we don't know what is cosec 38,2 degrees in the calculator, but we know that cosec is the reciprocal of sine, therefore 2 is still 2, there we go, but what is cosec 38,2 degrees? It's 1 over sine 38,2 degrees. You understand what I've done there? Okay, plus cos, where does the 439,2 degrees come from? It comes from this. Remember, 3 times 146,4 degrees is 439,2 degrees. Okay, then when you punch all of this in the calculator, now I know I have sine in the calculator, I have cos in the calculator, and the answer was 3,42, and that is the value of what was given. Well done. Now next we must look at 4.3. Simplify fully, underline, without the use of a calculator. Okay, what comes to mind? Special angles. Now, when we go to 4.3, let's check. This is what was given to us, okay? Right here. But what is sine 45? Sine 45 degrees using our special angles is 1 over square root 2. What is tan squared 60 degrees? Remember, it is tan 60 degrees all squared, but tan 60 is square root 3 over 1. Then don't forget the squared, okay? What is cos 45 degrees? It's 1 over square root 2. And then, when you simplify this, the 1 over square root 2 and the 1 over square root 2, they cancel, and you are left with square root 3 over 1 all squared, of which this will be 3. Okay? Wonderful. Now, the next thing that they are asking us to do is, if we are given that 5 cos beta minus 3 equals to 0, where beta is in the first quadrant, you understand what I'm saying? Where beta is in the first quadrant. Okay. If A plus B, if alpha plus beta, oh, that is alpha. If alpha plus beta equals to 90, okay, meaning now they are telling us that we are in a right angle triangle because of if alpha and beta add up to 90, meaning the other 90 degrees will make a 180 degrees, and that is sum of angles of a triangle, okay, in quadrant number 1. So, and also alpha is in the first quadrant. Calculate the value of cot alpha. Let's go to the solution and check how I've done that. Very simple. I started by first finding cos beta. Okay, so cos beta was 3 over 5, and I'm told that beta is in the first quadrant. So I've actually found what beta is. Okay, then I found that beta was 53.13 degrees. I went to what they gave me, which was alpha plus beta is equals to 90 degrees. I substituted beta. I found that alpha was 36.87 degrees. Ne? And then, after that, I went to the question of cot alpha. So, in a way, I was first trying to find what is alpha, since I had everything in terms of beta. So, after finding my alpha, then I was able to come and just substitute alpha. So, cot 36.87 degrees is the same as 1 over tan, the same angle, and my answer was 4 over 3. That is one way you would have done this problem. But the other easiest way is, I'm given that 5 cos alpha minus 3 equals to 0, meaning cos, not alpha, beta. Therefore, cos beta being equals to 3 over 5. Then I've checked, what do I have? I've got x, I've got r, therefore I found y. Okay. And why did I say y is equals to 4 only, not plus or minus? That's because I'm in the first quadrant. Okay. After doing that, then I said, therefore, cos alpha will be equals to 4 over 3. How did I know that? There is a sketch or a diagram. Okay. So I've used this diagram using beta and alpha. Look at what I've done in the sketch. I put angle beta and angle alpha together in that triangle because together they must give me 90 degrees. But I also have another 90, meaning this is correct. Okay. Then, since I have alpha in the diagram and having used what I obtained from cos beta, then also finding y, then I can be able to answer the question that was given. What will be cot alpha? Remember, cot alpha will be x over y. So what is my x? My x is, in this case, remember, the x over y won't work because now the position of the alpha is the other way around. Okay, but we know that cot will be adjacent over opposite. So alpha is adjacent to 4, and it's opposite to 3. Okay, that is the reciprocal for tan. So remember, if they are saying alpha plus beta equals to 90, angles that add up to 90 degrees, we call them complementary angles. Angles that add up to 180 degrees, we call them supplementary angles. Please note that. And then these things that were given here, they shouldn't scare you. They were just saying we are in the first quadrant. Okay. Now, having said that, let us go to summary of the lesson. We dealt with angle of elevation or inclination we dealt with angle of depression, then we went to application of how we deal with angle of elevation and angle of depression. Okay, now don't forget to watch part 1 of trigonometry, I beg you, and thank you very much for joining me in this lesson, and I hope you are going to get all your marks in trigonometry, and well done, sharp.